This is Lesson 1.2, Order of Operations. As we work through this lesson, I want you to consider the question, why do we use an order of operations? Let's begin today's lesson by working with several expressions that deal with fractions. Problem number 1 has us subtracting 13/16 and 1/8. Now if we're going to subtract fractions, we have to have common denominators. Since these two fractions do not have common denominators, we need to find the least common denominator of 16 and 8. Now there are several ways to do this. One way is to simply list the multiples of each denominator. I'm going to start with the 8 because it's the smallest in value. So 8, 16, 24. I'm going to pause there because I see that the first multiple of 16 is going to be 16, which means the least common denominator is 16. Now our first fraction doesn't need to change since its denominator is already a 16th. But our second fraction needs to change from an 8th to a 16th. So I need to ask myself, what do I take times 8 to get 16? Then using the bottom-top rule, I multiply the top of the fraction by the same value. That gives me an equivalent fraction, 2/16. Now, when we're subtracting fractions and we have common denominators, we only have to deal with the tops, or the numerators. So 13 minus 2 yields 11. The denominators stay the same. So the difference of 13/16 and 1/8 is 11/16. Let's look at problem number 2. We have a multiplication problem. So the first factor is 4/8 and the second factor is 8/9. When we're multiplying fractions, we typically multiply top times top and bottom times bottom. Before you do that, you want to see if you can cancel. So we look for factors that are common to the top and bottom of the fractions. We notice that the 8 in the top is common to the 8 in the bottom of this fraction. So we can cancel these factors out, yielding a value of 1 in those positions. Now multiplying 4 times 1 gives me the numerator of 4, and the bottom times the bottom gives me a denominator of 9. So the product of 4/8 and 8/9 is 4/9. Let's evaluate the expression on the right side of the screen as we review the order of operations. You will recall that when you evaluate an expression, you simply find the indicated value of the expression. Now you can see that you have multiple operations in this expression. So in order to find a uniform value, we want to follow the order of operations. The first step in following the order of operations is to evaluate any expressions inside grouping symbols. So we can see that we have 6 plus 5 inside a set of parentheses. So our first step will be to add 6 and 5. That gives you a sum of 11. You bring down the rest of the expression around the value that you just determined. Now the next step in the order of operations is to evaluate any powers. So you look through each term to see if any terms contain an exponent. We notice that our third term is 4 squared. 4 squared is 16, so we write that value directly underneath the value of 4 squared. We write down the rest of the expression, 48 minus 11 plus 16. Now the third step in the order of operations is to multiply and divide from left to right. Since we don't have any multiplications or divisions left, we can move to step 4. And that is to add and subtract from left to right. So moving from left to right, we see that we need to subtract first. So if I need to, I step off to the side and I write down the subtraction problem. 48 minus 11 yields 37. That expression value gets written in underneath the expression that yielded 37. I'll bring down the rest of the expression. 16. Now I need to combine 37 and 16. Once again, I need to work off to the side. I go ahead and set that problem up. 7 and 6 is 13. We group the tens. We get a sum of 53. So the indicated value of the original expression is 53. Let's use the order of operations to find the value of the given expression. Step number 1 says to evaluate expressions inside grouping symbols. However, in this case, we see that we have two sets. Whenever this occurs, we always start with the symbols that are on the inside. So we're going to first find the difference of 4 and 1. The difference of 4 and 1 is 3. So we're going to write that value down and bring down the expression around it. Now, since we still have a set of brackets or symbols of inclusion, we need to divide 32 by 3. Now I know that 3 doesn't go into 32 equally, so I'm going to simply rewrite this expression as a fraction. And that will let me eliminate the grouping symbol. So 32 divided by 3 is simply 32/3. And we know that we're multiplying in this position, so I can bring the multiplication symbol down and set my factor 3 to the left. Now we move to step 2, which is to evaluate powers. Now, since we don't have any terms or factors that contain exponents, we're done with that. Step 3 says to multiply and divide from left to right. Now, the denominator of our 3 factor here is a 1. So we will recall from the warm-up exercises that we're going to multiply the top times the top and the bottom times the bottom. But before we do that, we need to see if there are any common factors that we can cancel. We see that we have a 3 in the top of this factor and a 3 in the bottom of this factor. That means we can cancel these 3's out, which gives us our result of 32. So the indicated value of the original expression is the product 32. Let's evaluate a third expression following the order of operations. In this expression, we see that x equals 3. So our first step will be to replace each variable with the value of 3. So let's begin by rewriting the expression with the value in place. Now we begin to follow the order of operations. Notice we have expressions in the top and expressions in the bottom. This fraction bar acts like a grouping symbol. So what that tells us is that we are going to evaluate the top and then the bottom, and then finally we'll divide at the very end. So let's begin with the top. The top has 10 times 3. So that eliminates step 2 because there aren't any powers, and we can go straight to step 3, which is to multiply. So the product of 10 and 3 is 30. So the top of our fraction has a value of 30. Now we move to the bottom. 2 times the sum of 3 and 2. We once again follow the order of operations in the bottom. So we need to add 3 and 2 together. That gives me the value of 5. I need to bring the factor 2 down. Now, we don't have any powers in the bottom, so move to step 3, which is to add, multiply and divide from left to right. So the top stays the same at 30. The bottom, however, goes from the 2 times 5 to the value of 10. Now, our last operation is division, which is level 3 in the order of operations. 30 divided by 10 is 3. So the quotient 3 is the indicated value of this expression when x is 3. Okay, let's evaluate several expressions following the order of operations. Expression A is 1 plus 5 squared divided by 50. We don't see any grouping symbols, so move to step 2, which is evaluate powers. We see we have the second term of 5 squared. So let's evaluate 5 squared and write that value down underneath the expression. Write down the remaining terms around it. So 1 plus 25 divided by 50. Now the next step will be to divide 25 divided by 50. We can simply rewrite that expression as a fraction. So 25 over 50 becomes 25 divided by 50. Bring down the plus sign and the 1. Now before I go any further, I want to look at my fraction and see if we can simplify this fraction. Well, we see that 25 goes into 50 twice. So we can cancel the 25 to a 1 and the 50 to a 2. So that gives me an equivalent fraction of 1/2. So now I've got 1 plus 1/2. Now, when we're adding a whole number to a fraction, we can simply combine them. So we can say the answer is 1 and 1/2. Problem B. We have 12 times 6 minus 3.5 minus 1.5. So, following the order of operations, we need to start inside the parentheses. So I need to subtract 6 and 3.5. So if I need to, I'm going to work off to the side, and I'm going to subtract 6 and 3.5. Doing this lets me visualize the problem, regroup as necessary. So the value that goes in here is going to be 2.5. I'm going to bring the rest of the expression down around it. Now, we have subtraction and multiplication. Multiplication wins, so I need to multiply 12 times 2.5. Once again, if I need to, I'm going to work off to the side and set up the multiplication problem. I'm going to add the intermediate products. Now remember, when you're multiplying factors that contain decimals, the rule is multiply, then count. So I'm going to multiply, I'm going to count the decimal places, I'm going to move that number over in the answer. So the result is 30. So 30 minus 1.5. Once again, if I need to, I'm going to work off to the side. I'm going to subtract 30.0 minus 1.5. Gives me 28 and 5/10. So the indicated value is 28 and 5/10. Our next problem contains decimals and fractions. So the fraction bar in the middle tells us that we need to work on the top and then work on the bottom and divide last. So let's begin with the top. We have 5.95 plus 6.15. So I'm going to set that off to the side and work it out. 5 and 5 is 10. Regroup. So I have 12 and 1/10. I'm going to simply replace the expression with the indicated value. Divide by 2. So again, I'm going to work off to the side. Two goes into 12 6 times. Down to 0. 2 goes into 10 5 times. So the simplified result is 6 and 5/100.